In the last episode, we talked about how hydrogen can be the key to storing renewable energy and how crucial it is to smartly integrate electrolyzers into existing energy systems. But what happens if we take it a step further? What if a hydrogen power plant could be operated completely digitally and remotely? What kind of IoT infrastructure would be needed to control and monitor such a facility from afar? What role would data, automation, and even cybersecurity play in a fully digital hydrogen economy? That's exactly what I'm talking about today in the next episode with Philipp Glaser and Mariana Sigoli. We'll briefly discuss what consequences this could have.
Get ready for hydrogen.
A Siemens podcast with Michael Pretorius and Philipp Glaser.
Philipp, maybe you can start by giving me a holistic picture of what it looks like when such a fully digital facility is up and running. What components and processes are involved, and how that differs from a facility that isn't fully digital?
Exactly. The digital hydrogen plant is what everyone is currently pursuing, and rightfully so. It makes perfect sense. Hydrogen plants built repeatedly with similar designs benefit greatly from digital integration, especially when they incorporate many innovative components and involve new market players. Plants that, as you already mentioned, are intended to be operated remotely and similar things. We're experiencing a very special momentum here. I'll get into the digital plant in a moment. Start right from the beginning with basic engineering, with the FEED study, by focusing on digitalization, because then, in the end, you'll have this digital plant that offers you better operational capabilities as well as other possibilities. It enables scale-up, replication, and similar processes. So what is the digital hydrogen plant? Just to summarize briefly, we've already looked at it in quite some detail in the previous episodes, so here's a quick recap. It's the digitalization process of the plant, which essentially consists of three main elements: automation, the digital twin of all components of the plant within an object-oriented digital twin model, and simulation models that I can use both during engineering and later in the operational phase, for example, by using deviations from simulated data to gain insights. These three elements, automation, simulation, and the digital twin, form the core of the digital plant. In addition, we have what we call the Hydrogen Performance Suite. A comprehensive cockpit, a set of cockpits that are specifically designed to serve as the user interface for the various people and roles who interact with the digital hydrogen plant. There we also integrate external data such as meteorological forecasts or information on electricity grid prices and other relevant data, for example. And thirdly, we have absolutely and completely pre-engineered the entire hydrogen plant, this digital green hydrogen plant, within our so-called technology stack. So to summarize, the digital hydrogen plant is created from the digital twin, the simulation, the automation, plus the hydrogen performance suite and the technology stack, which is pre-engineered and prepared.
Now I basically have the software in front of me, where I can see all the components that will actually be out there on the site. I also have something like a flowchart where I can see which processes are taking place inside. It means I can view them on the computer even before I start them in the real world. I can also simulate the performance, what would happen if I do it this way or that way. I can even already see, okay, there's a component that will fail tomorrow because of wear and tear. So this predictive maintenance, which you mentioned earlier, is also included in this digital twin. And now, there's the added component that I can, of course, not only operate the whole thing on site, but also from elsewhere. So remote operation is possible, which brings up a whole different set of questions. Questions also arise, such as what requirements are set by the operators, what specifications exist for load management, and so on. Maybe, Mariana, you could give us a deeper insight into what that means from this perspective?
Yes. So the utility operator, so the grid operator has the job to also is able to not operate directly the plant, but send requests for you to reduce the power that you are consuming at the point of time X, Y, Z because of reasons, right? And also, if you are not fulfilling the grid codes, it can completely shut down your plant. And therefore, you can, if you are going on more remote operations, you can do that sitting somewhere else, as you said. And how to do that, you can use IoT systems that can help you on monitoring your plant. And I think I would like to touch more on the point of the maintenance and the predictive maintenance that you can make with it. We do have the different toolings that Philipp mentioned, one of them being our platform called Electrification X, that you can bring the data of your power distribution system, of your complete substation, into a cloud. Can also be on-premise, but let's talk about cloud now. It can be a cloud so that you can monitor your power distribution system, also your switch gears, your transformers, and so on. And then you can already identify beforehand if something is going to is not in the right conditions. For example, temperature is too high and something is strange. So we always say that our switch gears are maintenance-free, but they are not service-free. You still have to keep an eye on them, because depending on where do you store or where they are installed, and if some operations are not running well, you can have problems with humidity, with temperature, and this can cause a huge damage. And I guarantee you don't want your plant to explode, that your switchgear explodes, because it's a very capex topic. So you pay a lot of money to buy a new switchgear, which is good for Siemens, but that's not what we want, right? We wanted to use our systems in the best possible way. And therefore, we are creating such platforms to help you to remote monitor your plant. And then with this information, you are able to remote operate your plant in the best way possible. Also having a look in the eye of the substation, because it's one important topic, of course.
Let me break it down with a very simple and straightforward example. If I'm driving in first gear at 90 kilometers per hour, then my tachometer is going to shoot way up. And as the driver, I should actually be able to hear that my transmission is about to blow up. But in this case, the data isn't just in front of my eyes on the dashboard, it's in the cloud. And now, a remote expert could also support me and say, go ahead and shift into second gear. If you want to protect your transmission, or wait another 30 seconds, and a red light comes on here. That means these cloud solutions you're talking about also make it possible for me to operate in an industry that is still very new. Where perhaps not all additional skilled workers are available, I can bring in highly qualified experts who can provide valuable support. Or I can even get a comprehensive performance analysis from other detailed specialists, or tips regarding my business model. Or did I misunderstand that?
No, that's totally true. Correct. 100%. Exactly. Can give you the suggestions saying, look at this point because something is not, might be problematic, might be not, but you can already plan your maintenance beforehand. Like you're planning your maintenance instead of in 1 year, maybe you do it before because you see already that something is not going in the right range as expected. Yeah?
You just mentioned how important it is to rely on a digital twin from the very beginning. To build a digital hydrogen plant, is it a critical mistake?
If I say, yeah, we'll start off only partially digital and we can retrofit the rest later, well, it's extremely important. In such plants, we need a concept that works with standardized templates. The plants need to be standardized, but also the individual plant components themselves should be standardized in order to achieve a certain level of modularity. This standardization in the plant components can also be implemented, for example, if you have a suitable template in Comos, our engineering tool, or also in automations. Here as well, work is essentially done using templates nowadays. For example, our control module templates are also highly standardized. There are the so-called MTPs, the module type packages, which are even standardized across different manufacturers. Of course, there are some functional limitations because there's a high level of standardization behind it, but this is all part of the area that is feasible and one that needs to be carefully considered when starting out, what to use and how to use it. But it should be modular. And on the other hand, of course, I still try to do everything I can to learn and to design and operate the entire system for a life cycle of around 20 years or more. Because the investment in such a green hydrogen plant is not something that pays off in 5 years. We're indeed talking about significantly longer time frames. And that's a very important aspect, which, by the way, we can of course also bring into discussions with the relevant customers who talk to us about it. Because the people you meet here, Mariana, myself, our teams behind the scenes, are all individuals with decades of experience in building plants, in constructing process engineering facilities. And that's our daily business. That's what we're used to. Discussing with specialist departments from large companies in the process industry, developing concepts together, and we understand precisely and thoroughly what absolutely needs to be done to design a plant for such long time frames and to find the right concepts. By the way, I always loved this topic. For decades, I've been working with such specialist departments from process industry companies, along with the team supporting us. But here, a really great aspect comes into play again, namely that in a hydrogen plant, entirely new players are suddenly entering the scene who don't have this background at all. And that creates something really, really exciting because they challenge us with their new ideas that we might not have come up with or even heard about in the past 20 years. And on the other hand, we of course contribute to the whole thing with our many years of experience, which is absolutely necessary to get a process engineering plant like this under control. So it's a very exciting topic that I think all of us really enjoy working on together.
You just mentioned the return on investment, meaning how long it takes for a system like this to pay off. Now, you also brought up predictive maintenance, the servicing of parts that cost money. But you also just mentioned the topic of power distribution, Mariana. And that's a major lever. At what price am I buying electricity? Do I have to pay a penalty if I feed too much electricity back into the grid? And I just gave the example of driving a car at 90 km/h in first gear. And now you just told me that my system is being shut down remotely. Imagine someone saying, I will slow you to 20 km/h because you are revving too high. What parameters, sensors, and automation exist in a digital hydrogen plant to make these necessary and feasible?
Exactly. Maybe one concrete example exactly of this question, right? We say, okay, we come with the idea, let's do a complete autonomous operation with a digital plan that can do a lot of things. And then when we start going backwards already on the design of the power distribution and the connectivity to the grid, you start asking the question, okay, but did you know what you needed in order to do that? I talked about this platform, Electrification X. In order to have the information in the cloud, you need to have the sensors installed locally in your switchgear. And you know where the sensor goes? If you open the switchgear, you have the main circuit breaker, the core of the switchgear. I call it even the heart of the switchgear. You need to install a sensor exactly there. Can you imagine how it's going to be complicated to do that if you don't do early stage in the design of when you're starting in the pre-engineering, in the feasibility, already very early on the design of on the engineering design, on the basic design. If you are not considering such things, how difficult it will be to do that on site already when you have everything, all the equipment installed. You need to open the switchgear, take it out, install the sensors, and then talk about the software. So the software comes, of course, important and will help you on the operations and during a maintenance period, but that's much later. The discussion has to start already in the basic design and the detailed design engineering phase, because this is really affecting how the sensor will be connected, how many sensors, where do we put the sensors, and how to bring this information up via the automation system, and then in the upper layer, looking at the architecture, right? Looking at the IT/OT layer.
And now let's assume we have all this data, these sensors for temperature, for pressure, for gas flow, for energy consumption. We also have the sensors with safety monitoring, and now I'm operating my plant in one country. Philipp is operating his hydrogen plant in another country. You, Mariana, are operating a different hydrogen plant in a third country. Your plant, Mariana, is a bit bigger than mine. Philipp's is gigantic. We didn't even imagine one that big. And now we have different data, but all of it is stored in the cloud. And now a fourth operation wants to get started. Can this operation already benefit from the data generated in our 3 plants? Or is everything completely independent?
For sure, it can make comparison, right? And then see, okay, maybe first of all, how how big I would like to have mine, or how can I operate mine best because of the other parameters. So you can compare and make this benchmarking with each other, with the other plants, right? And say, okay, then I can, I see that the hydrogen market will go a little bit how the renewable market's going. And when they talk about blockchain, how can I sell my electricity to my neighbor and not necessarily to the grid operator? So it will come to that momentum, I believe.
That means, as an operator, I decide myself whether I make this data available to others. Or is it collected by companies and then anonymized in your consulting? Or how does that work, Philipp?
So we do not collect any data about these systems. That's already a very, very important point. The question, as we understood it from you just now, is about the technical possibilities. And this possibility of collecting data across different systems, that you gather it in a fleet management system, trying to learn from it because you have different operating conditions and can then observe how those conditions affect the systems. By comparing exactly these kinds of situations and systems with one another, there's a lot of potential in that and a lot is possible. And of course, we offer these technologies in every respect, both to ensure that you even have the data in the systems at all, at the system level, and that you can actually do something with it, but also on a higher cloud-based level or through other mechanisms of fleet management. The Hydrogen Performance Suite already offers fleet management capabilities that can be used to bring these elements together and get more out of them. And of course, this is also an invitation to everyone listening who says, I'm not just interested in a single plant, but I want to build multiple plants in different countries. But of course, that certainly also brings to mind other players beyond just those who build the plants themselves, but also those who support and facilitate the construction and operation of these plants in various locations around the world. Indeed, this is a comprehensive endeavor that involves numerous stakeholders and varied interests. Namely, the plant engineers, for example, the licenses behind them, or also the manufacturers of electrolyzers, who deliver their electrolyzers to various countries in different configurations. And of course, they would also be the ones to monitor the behavior of the electrolyzers across these different operating conditions, performance curves, ramp up, ramp down, degradation, and everything else that goes along with it. That's where the market comes in. We show the market our offerings, capabilities, and implementations. But then, of course, it's also to some extent up to the market, that is, plant engineers, licensors, electrolyzer manufacturers, and plant operators to decide, what do I do with this? Who do I share which data with? Who is allowed to access what? And in return, who offers me which opportunities for performance optimization, improved maintenance, and so on. That means an opportunity for all parties involved to collaborate more efficiently based on data, to make the plants more efficient, but also, for example, to implement new business models. There's added value in that as well. As a plant engineer, licensor, or electrolyzer manufacturer, I can of course also build a business model on such things. We offer these possibilities and we also discuss them, and we're happy to help with that. But in the end, the market itself has to implement and realize these things together.
I can already tell. If you want to get into this business, you really need to get to know the two of you. And ideally, you start with a digital hydrogen plant from the very first second. That makes maintenance, as I gather, a bit easier. I have more opportunities to collaborate with other players in the same market. And I also have the opportunity to further develop my business models digitally. Thank you both very much.
This podcast was done by humans but localized with the help of AI. Thanks for listening.